Hello, today we're going to be going over representing relations. So, we have some new vocab words today. We have relation, domain, range, mapping, independent variable, dependent variable, and scale. All right, let's get those words highlighted. First section we're going to talk about deals with relations, domain, range, and mapping. Learning about relations. These are mathematical relations we're talking about. You can use math to represent the relationship between two sets of numbers. For example, suppose you recorded the number of minutes you spent driving from your driver's training course each day for a week. You may use the set 1, 2, 3, 4, 5, 6, 7 to represent the days and the relation. And the set, 30, 45, 20, 40, 45, 90, 60 to represent the minutes. So we have 7 entries and then 7 data points. The relationship between the sets pair each day with the time driven that day. This pairing of the number is called a relation. So example, if we were to put these together, we would have a point 130 because the first day we drove 30 minutes. The set of days is the domain. And the relation and the set of times is the range. So the set of days is the domain of the relation, and the set of times is the range. A relation is a set of ordered pairs. The set of the first number of the ordered pair in a relation is called the domain. The set of the second numbers of the ordered pair is called the range. So, for domain, we have our first set of numbers. Now, the domain is also our input. So over here, this is the input. And input is independent. Our second order, in an ordered pair, these are our y values. This is the range. The range of a data set is dependent. And it's the output. So domain is independent and is an input. Range is a dependent output. A relation can be represented in multiple ways. A mapping illustrates the relationship between the domain and the range. So part of what we're going to do today is learn how to map these 2 points together. And there's a bunch of ways we can do this. No, wrong color. An equation shows a relationship between the domain and range. Relationship where substituting each value in the domain for x results in the corresponding y value of the range. The x values in the domain and the resulting y values can be written as ordered pairs and are called solutions of the equation because they make the equation true. Below is a mapping, table, graph, and equation of the relation 3, 5, negative 4, negative 2, 0, 2. All right, so we have the equation y equals x plus 2. First up, when x is 3, y is 5, because when we plug in 3, we get 5. So when x is 3, y is 5. When x is 3, the output is 5. And then we have 3, 5 up. When x is negative 4, y is negative 2. When x is negative 4, y is negative 2. When x is negative 4, y is negative 2. When x is negative 4, y is negative 2. Finally, we've got when x is 0, y is 2. It shows over here. When we plug in a 0, the output is 2. When x is 0, our output is 2. When our x is 0, the output is 2. And think about it. Compare the table and the mapping of the relation. What conclusions can you draw about the x and y coordinates and the domain and range? Well, we've seen. So domain values, every x matches with a y. In an equation, if the number we plug in from the domain will have a corresponding number in the range. Use the data set 2, 0, 0, 4, 3, negative 5, and negative 3, negative 5. Part A, express the relation as a table, a graph, and a mapping diagram. As a table, we have to do this as xy. So go x. And we have our y's. There's 1, 2, 3, 4 pieces. So 2 slots, 3 slots, 4 slots. And y. List the x values: 2, 0, 3, negative 3. And we make our y values: 0, 4, negative 5, and negative 5. Now, for sake of completion, let's put these in order, because our x values, to look right, should always be in order. So negative 3 is our lowest, and that followed by 0, 2, 3. Negative 3 goes to negative 5, 0 goes to 4, 2 goes to 0, and 3 goes to negative 5. Now they want us to graph these points. All right. Red and blue make purple. Negative 3, negative 5. 1, 2, 3. 1, 2, 3, 4, 5. 0, positive 4. 0, 1, 2, 3, 4. 2, 0. X is 2. Y is 0. 3, negative 5. Oh, we got to put those Y's there. X is 1, 2, 3. Y is negative 1, 2, 3, 4, 5. Mapping diagram. We have the domain, negative 3, 0, 2, 3. Then we have the range, negative 5, 4, and 0. Now notice that the range is smaller than the domain. This matters later on. So just remember, there are instances where the domain and range are different sizes. Negative 3 goes to 5. 0 goes to 4. 2 goes to 0. 3 goes to negative 5. So we have our table, our graph, and our mapping diagram. All right, moving along. Part B, determine the domain and range of the relation. The domain of the relation is negative 3, 0, 2, 3. The range of the relation is negative 5, 0, 4. Well, we had that, yeah. And our mapping diagram tells us that. This is called set notation. A set notation is when you have a bunch of numbers. So again, these brackets are for sets. So whenever you see these squiggle brackets, they mean it's a list of numbers that represent something. We have our domain, and our range. All right, check time. Take a moment, pause your video, and try your best to solve this. Welcome back. All right, let's do this. List the ordered pairs in each relation. The table. All right, we're going to make a list of ordered pairs. So, because we're building a list, the first thing we should do is do a bracket to show that this is a list. So I'm going to put a squiggle bracket in, and then in this list is going to be ordered pairs. So in the table, I have negative 1, negative 5. 4, 7. I really should be making those commas pink. We'll do that for the next one. Negative, parenthesis, negative 2, 3. So we have a set of ordered pairs, and ordered pairs are just two numbers pretending to be one. All right, on the graph. So again, going to have some ordered pairs. Negative 1, 2. Negative 1, 2, 3, 4. Negative 1. Positive 1, 2, 3. Positive 1, 2, 3, 4, 5. Positive 1. That shows a little bit cleaner. So we see that we have commas in our ordered pairs that show the two numbers of our unit that we're looking at. And then we have the commas of the number set. Finally, we have our last one, the mapping diagram, domain and range. Three ordered pairs again. 1 goes to 5. 5 goes to -1. And -6 goes to -1. Again, notice we have a situation where the range is smaller than the domain. Remember, that comes up later. This is something special when the range is smaller than the domain. All right, let's move on. Learn. Graphing the total time driven during your driving course can help you visualize the progress. A relation can be graphed without a scale on either axis to show the relationship between the independent and dependent variables. These graphs can be interpreted by analyzing their shapes. The values in the domain correspond to the independent variables in the relation. The independent variable, these were the ones we didn't talk about from the beginning. So, independent variable is an x value. So what we want to do over here is we have independent. The independent variable, x value, and is the domain. This is the input. The dependent is the y value. This is the range. And this is the output. The independent value is what we plug into an equation, and the dependent value is what we calculate from that. The values in the range correspond to the dependent variable of the relation. The dependent variable is a variable in a relation, usually y, with the values that depend on x. In the graph above, the dependent variable is the driving time. So we see the days of the week, and if we recalled, our days were 1 through 7 going that way, and our driving times were over here, and they did change throughout the day. The graph represents the number of text messages sent by Nora throughout the day. Identify the independent and dependent variables of the relation. Well, this is our x-axis, and this is our y-axis. From what we talked about, the independent variable is attached to the x. So that means time is independent. So if time is the independent, the dependent variable is our y-axis. So that will be the number of text messages sent. As you move from left to right along the graph. And what this means is as our x value increases, time what happens here. And what's going to happen is as we move from left to right, time is going to increase. So x is going up. and the number of text messages sent. We zero whatever this number is, then we sent another, then we sent some more. So text messages increases. Until the graph becomes well, the graph's going to become a continuous graph of text over time. We don't know exactly what the time is, but this is just going to show us the total number of texts sent whenever we stop. So this will be a continuous relation. As time goes on, whatever our starting time is, texts go up. The horizontal line means that time is increasing. But the number of text messages sent remains the same. So what they mean by that is when they say a horizontal line, they mean this part right here and this part right here. So during here, let's say you sent 5 text messages, and then time passes and you haven't sent any more. So this is going to keep going with every second you don't do another text message. Then you send a couple more text messages, you're on your new one. And then if you're, let's say this is 9, you're at 9 text messages, you're still at 9, you're still at 9, you're still at 9, then you start blowing up someone's phone. So horizontal line means that as the independent variable increases, the dependent does not. During this time, Nora is not sending text messages. Then she continues to send messages. Oh, okay, I got what it's saying now. Yeah. So as time increases, text message increases, we hit the horizontal line. Then as she continued to send text messages until we hit the end of the graph. Does it tell us how long? She again for a period of time. Then she continued to send text messages until she blanked again for a period of time. So, the way to see it. This part right here represents this part of the graph. This horizontal line represents this. This part right here represents this. Then she continued to send text messages until she's. So we have she continued to send, stopped for a period of time, and then finally we have this final part, which is over here. We'll go back to green. We'll do red-green for that one. Christmas colors. Nora finally began sending text messages again. Check. Identify the independent and dependent variables in each relation. All right, pause video, take a chance. Welcome back. First up, the average price of a ticket is the blank. The average price of a ticket to an amusement park has steadily increased over time. So the average price of the ticket is dependent. time is the independent. The air pressure inside a soccer ball decreases with time. Time is the independent. Air pressure is the dependent. Notice that the independent variable usually is a rate. So like time is a rate. Time passes at 1 second per second. So usually an independent variable is a rate of some kind. Two more checks and that'll be all for now. Airplanes. After an airplane takes off, its altitude increases rapidly. Once it reaches the desired altitude, it continues to fly at that level for a short period of time. Then the plane's altitude fluctuates slightly due to turbulence. Finally, the altitude decreases quickly as the plane lands. Which graph represents this best? All right. Pause video, take a chance to work this out on your own. And when you start again, we will come back. For all of those watching now, let us continue. So, after an airplane takes off, the altitude increases rapidly. All right, so we're looking for a steep increase. All right, that's a steep increase. That's a steep increase. That's a steep increase. Altitude rapidly picks up. So we got to see that's not that rapid. That's kind of flat. So C's out for me. Let's add more data. Once it reaches the desired altitude, it flies at that level for a short period of time. This one shows short. This one shows short. So A's out because this looks long. They said short, and these ones are significantly shorter. Then the plane's altitude fluctuates slightly due to turbulence. All right, so now we're between, since altitude is the dependent, that means it's going to fluctuate. Fluctuate means going up and down, but it's only fluctuating slightly. So in B and D, well, this one goes up and down way more than this one. So if I had to say which one of these two was slightly, I go with B. We're pretty much only got one option left. Finally, the altitude decreases quickly as the plane lands. So B is the only one that matches. Now I will say that matches and that matches. And for the level of a short period of time, that matches. So if we take a look, we have a couple colors of information. And from those colors, we can match them to the graph. And the only graph that has all the colors on it is B. All right, last one. Traffic. Kane noticed the traffic congestion on his street on weekday mornings depends on the time of day. He draws a graph to represent the relationship between the time of day and the volume of traffic congestion. On his street on a weekday morning, analyze the orange segment. Select the segment that describes what is happening during this time. I'm going to guess this is supposed to be orange. What segment's orange? Be right back. Let me find the colored version of this real quick. My apologies for that. The orange section, which this does not do any efforts to let us know, is actually right here. So with that bit of information, you can pause this and take a chance. All right, let's see. So what we see here is that as time increases, the congestion goes down. So we're looking for an answer where time is going up and traffic congestion is going down. Traffic congestion is steadily increasing. Nope, we need it decreasing. Traffic congestion is constant. No, that's constant. Traffic congestion is constant and very heavy. No, that's up here. Traffic congestion is decreasing at a steady rate. Now, what steady rate means is it's not like doing this, then this, then this. It means it's making a straight line. Decreasing at a non one might be like, here's a. It's going down, but it changes its angle with each segment. So a steady rate gives us a straight line, and that's what we got. And that's it. Have a great day. We'll be back later with part 2.